Lesson 6, Modeling Data Using Logarithmic Functions. So for the first one, we're just going to make a scatter plot. So you plot each of the points. So we have 2 and 10.1, which would be in here. We have 5 and 12.8. We've got 8 and 14.2. 12 and 15 point, oops, that should be like this, 15.5, 16, 15, and 16.1, and 18 and 16.7. So you can tell this is a logarithmic function. The function would go through 1 at the bottom, and it would look like that. So when we have our data scattered in a way that it is logarithmic, we can use our graphing calculator to plot the points, then find the regression line, which we've done multiple times. We just push a different button this time. So with our graphing calculator, for example 2, we're going to plot our x's and our y's. So the first thing we do is make sure your calculator is completely erased, so pause the video, make sure you did that. Okay, now we're going to plot the points. So you're going to hit Stat first, 1. Then you're going to hit Edit, so you hit the 1 button. That will take you to the L1, L2 screen. Now you're going to plot all your points using Enter between the two. And it should look like this. So we've got our percentages in for X and our number of flashes in for Y. So now what you're going to do is you're going to plot it to see if it's exponential. So you're going to hit Zoom for 1, and then 9, Zoom Stat for 2, and it'll look like this. So you can see that this is exponential decay. It is decreasing. Now we're going to graph the regression line. So we're going to hit Stat, and then you want to hit Calculate, so 1. And now this time you want to get the logarithmic, the ln reg. So your screen should look like this. So you got to go down all the way to 0. So either you can push 0 or you can push down until you get to ln reg. Push Enter, and Enter again, and it'll calculate your logarithmic regression, which will look like this. So now we have a value for A and a value for B, and it tells you how to write the regression line. So we have y is equal to A plus B ln x. So you have 0.459 ... plus 0, or sorry, that's minus 0.0998 ... ln x. So there's the equation for our logarithmic function, y equals. If you wanted to graph the logarithmic equation, to see it, you would use your vars key. So you'd first click on y equals, and you want to click vars 5 for statistics, and then overwrite to EQ, which will bring up your A and B values, and we would push A to get A, and we would type it in, y is equal to A plus B ln x, and it should look like this. So you use the vars keys to get your A and your B values. Then you can graph by hitting the graph button, and it will look like this. So there's the equation of the regression line. So it matches the data perfectly. So the next example is the exact same thing. We want to graph the logarithmic regression. So I'm going to just show you which points to plot for this one, and you have to get to the right answer yourself. So again, you're going to push stat. Then you're going to push edit. So stat, edit, then type the numbers in for X and Y. So pause the video and type all your numbers in for X and Y. Now your second step is you're going to push zoom and then 9 to see your logarithmic data. So zoom, then 9. Now you're going to calculate the regression. So you're going to push stat, calculate, and then you're going to push 0 for the LNREG. So stat, calculate, 0 for LNREG. And the numbers that you should get are A is equal to 44.4160462 and B is equal to negative 8.364086594. So our logarithmic function is y equals 44.42. We're going to go to the nearest hundredth, minus 8.37 ln x. So now we're going to use this equation to figure out data. So it asks. So we're going to use this equation to determine the time it takes for the person to metabolize 50% of the caffeine. So we're starting with 200 milligrams, so that means 50% would be 0.5 times 200, which is 100. So 100 milligrams goes in for x. So we have y is equal to 44.42 minus 8.36 log of 100. And you type that all in, you should get 5.9 hours. And for the last one, if a person took 200 or drank 200 milligrams of caffeine at 10 a.m., how much caffeine is in their system at 9 p.m.? So that is 11 hours. So we're going to plug that in. Y is equal to 44.42 minus 8.36 log of x. We have y is equal to 11, which is 44.42 minus 8.36 log x. Now we're going to subtract the 44 to the other side. And you have negative 3.42 is equal to negative 8.36 ln x. Then we're going to divide by negative 8.36. And you'll get 3.9976. And that's equal to ln of x. Now we need to solve for x, and we can't do that unless we change this to an exponent. So this would change this to x is equal to e, because it's a natural logarithm, to the power of 3.9976. Remember, you always put your exponent first when it's the logarithms. So you type in e to the power of 3.9976, and you get x equal 54.467. So roughly you have 54.5 milligrams of caffeine left in your system.